Hello, my name is Ruby Pittman, and today, on the 22nd of January, I struggled with problem 23 on my math final. Now, there are many things wrong with the number 23. First of all is Miley Cyrus's song. Third of all is, actually, I don't have a problem with Michael Jordan. He's pretty cool. Pretend this is Miley Cyrus. But I associate 23 now, not with all of those material items, but with failure. The sense of failure. Yep, that's priceless, alright. Now, this problem had 4 parts. Part A, B, C, D. And another problem that it had was that I couldn't solve it. However, I will be solving this problem by solving this problem. Yes. Now, part A dealt with finding a degree through finite differences. We'll solve that in a sec. Part B was, I believe, I'm getting this off the top of my head just through photogenic stuff, was to find an equation that modeled the function. Actually, part A was to finish the table. Part B was to find the degree through finite differences. Part C was to model the function, and part D was to apply it after 30 times, or 30, like the value of x being 30. So we will complete part A, B, C, D, and inevitably E today. Now, let's make a table. This is what was given in the problem at hand. Let's switch to a teal color, shall we? Now, we were given 5 values, essentially. Okay, pretend that this is 5. So we have our x's, we have our y's. So we have 1, 2, 3, 4, 5, 6, and 7. Now this is what it looked like on the test. And we had these little dots. They signified balls. Yes, Miley Cyrus. Okay. Anyways, they signified balls, and 5, 6, 7 was our second term. 1, 2, 3, 4, 5, 6, 7, 8, 9 was our third term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fourth, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 was our fifth. Now, this is an irrelevant drawing to our graph, but it does help us solve for our 3, 4, and 5 values, which if we count 7, 8, 9, 8, 9, and then that would be 9, and then 9, 10, 11, 12 would be 12, and then 9, 10, 11, 12, 13, 14, 15, 16. Bam. Now, through this, we can solve through finite differences the degree of the function. Degree. Hopefully one day I can get a degree in math. But shooting for science, I don't know. Who knows? Now, if we take these values for y, we have 6, 7, 9, 12, and 16. Bam. Now, no matter which way you subtract them, you will get -1, -2, -3, or -4, or you could get 1, 2, 3, and 4. And this is a 0th degree. Now, some people might say, oh my gosh, there are numbers, whatever. Well, 0th degree. And it's not a 0th degree because these answers are not finite. They are not congruent. They are not the same. This is 1st degree. We sort of went down one trophic level, basically, if you want to think biological terms. And then the differences between these numbers, if you just take out the little, you make all these positive or something, it'll be 1, 1, 1. Bam, 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 bam. We'll have a 2nd degree polynomial. And a 2nd degree polynomial is also classified as a, yep, you guessed it, folks, a quadratic quadratic. Now we have answered and knocked out of the park, might I say. Pretend this A is just going out of the park. Question A. We have answered that it is a, let's use some maroons. Second, wait, what? Let's, okay, why isn't it changing colors? Okay, let's do some pink. Yay! Second degree polynomial. Cool beans, y'all. Now that we have that this is a second degree polynomial and that it models a quadratic equation, we shall write the formula for a quadratic equation, folks. So that is y equals ax squared plus bx plus c. Oh crap. Question B asks for you to, whatchamacallit, it asks for you to model an equation. Pretend it doesn't say and twice. Equation. So it tells you to model an equation. No, not just present the equation model, but model an equation from the given data. So at first I was like, hey, I modeled an equation. I know this is quadratic. I get it. Then I pretend this is problem C as well. Then I looked at problem D where it asked me to solve after 30 terms, and I was like, hey, what? What? Man, no. Data. So, you want to solve for A, B, and C. And remember our data points. We have 1, 6, 2, 7, 3, 9, 4, 12, and 5, 16. Now, as you see, we have values for x and y. So we have x, and then y. So basically, every time we plug in x and y from our key data points is one step towards solving the values for A, B, and C, because we can use the beautiful process of elimination. Bam. Hearts for days for elimination. It is a beautiful process. Now, our first data points, let's write down our little data points here. We have 1, 6, 2, 7, 3, 9, 4, 16. Wait, is that even right? Yeah, no, 4, 12. And 5, 16. Beautiful points, I tell you. This will come out for a beautifully solved equation. So, if we plug in our values for x and y for our first key data points, which will be, let's choose 1 and 6, and let's also call this equation equation 1, because see, our value for x is 1, it just fits. So, we'll have 6, which is our value for y, equals a times x, which is 1, squared, plus b times x, which is 1, plus c. And this simplifies to, let's move this over here, so we'll have a plus b, so we're making this fly over here. My teacher always uses these like weird fairy wings, so I'm going to use those too. Plus c equals 6. Boom, that's our equation 1. Now, equation 2, let's put it in a different color. Let's put it in bubblegum color. It will be 7 equals a times 2 squared plus b times 2 plus c. Bam. Let's make this fly over here. Put some wings on it. Like, give it some Red Bull. Pretend those aren't 3s. So then we get 4a plus 2b plus c equals 7. And then let's use some Spindrift. I don't know what kind of color name this is, but we can do 9 equals a times 3 squared plus b times 3 plus c. And then we get, let's make this fly over here. My gosh, what's wrong with me? Just keep it over there in the first place. 9a plus 3b plus c. And then our last and final equation, let's make it really hot. Let's make it some maraschino. That's the name of this color. 16 equals a times 5 squared plus b times 5 plus c. So we get 25a plus 5b plus c equals 16. So with our equations at hand, I'll circle them in a one of the 50 shades of gray here, and I'm given so many shades of gray, and it's like, where are the other colors? Okay, we have these three equations. Yeah. So with these equations, we have equation 1, equation 2, equation 3, and equation 4. Now to eliminate our value for c first, it looks like the most attractive mate for elimination right now. Again, if you want to think in trophic level and ecology terms, think of this as the little producer that is gonna get like eaten. Okay, cool. I love you, Miss Simon. Shout out. Anyways, now we'll take our equation 1, which is a plus b plus c equals 6, and then we'll combine that with equation 2, which is 4a plus 2b plus c equals 7. Now with this equation, we see that we can multiply the top equation by -1, and we get -a minus b minus c equals -6. We get 4a plus 2b plus c equals 7. And whoa, look at this. These two values cross out. Let's use a vibrant color to represent our next equation. And then we get 3a plus b equals 1. That is we'll call this our 1/2 equation, because it is a mixture of 1 and 2 combined. Now let's go back to one of our shades of gray. Let's go to the iron shade. I think that's what we're just on. And let's combine equation 2 and equation 3. Now I believe equation 2 is right here, so it says 4a plus 2b plus c. Yeah, okay. Equals 7, and then we have what should we call it? 9a plus 3b plus c equals 12, or equals equals 9. Yes. Yep, equals 9. So, what we will do is we will multiply this top equation by -1. And as you see, I'm multiplying all of the top equations by something, because those are the equations in order of 1, 2, 2, 3. The top equation will have lesser values. So in the end, it's simpler, and in definition, it's working smarter, not harder. So then you get -4a minus 2b minus c equals -7. Then you get 9a plus 3b plus c equals 9. Now when you combine these two, let's use that maroon color again, you will get 5a plus b equals 2. Yes, it equals 2. So we'll call this our 2/3 equation. Now as we can see, we have a really attractive, some attractive b's that just want to cancel out with each other. Ooh, yeah. So we will combine them real quick. So it will be our 1/2 and then 2/3. I'm using all the shades of gray in this presentation. So we'll have 3a plus b equals 1. Then we'll have 5a plus b equals 2. Now, our top equation again is just the easiest to solve. Just multiply that baby by -1, and we will get -3a minus b equals, equals -1. And then we'll get 5a plus b equals 2. Now, when we combine this, because these cancel out, we get 2a equals 1. Now, very simple algebra from here on out. We get that a in decimal form equals 0.5. Now, let's highlight this in eggplant. Oh yeah. So let's use this little space to solve for b. Then we will go ahead and easily solve for c. Let's use nickel, the nickel color. So we have that 3 times our value for a, 0.5. I'm using the easiest equation to plug it in, plus b, which was sort of too in love to be canceled out, I guess, equals 1. And we get that 1.5 plus b equals 1. Minus 1.5, subtract 1.5 from the other side, we get that b equals -0.5. Who says b can't be -0.5? Who says you're the only one that's worth it? Trust me, that's the price of beauty. Okay, I'm done singing Selena Gomez songs. Let's get down to math business. Now that we have that a equals 0.5 and that b equals -0.5, yes, we are 2/3 of the way there. And then that c equals question mark. We can plug it into that really easy equation that we had earlier. Remember the one that the one that says that a plus b plus c equals 6? Whoa, that's too easy to handle, man. So we will have a plus b plus c equals 6. And we will have 0.5 plus -0.5 plus c equals 6. And then we will have 0.5 minus 0.5 cancels out, plus c equals 6. So that means positive c equals 6, which means c equals, okay, let's erase this question mark. It's getting on my nerves. We have answered the, okay, wait, awkward. We have answered, wait, okay, again. We have answered the problem, people. Let's use some teal. C equals 6. So now we want to sort of check our work, because this is what happens to me. I need to check my work. I'm like thinking I'm some mathematician in Algebra 2 trig class, and I'm like, yay, I'm cool. So let's go back to our equations. So we obviously know that it matches in our a plus b plus c equation. Let's plug it into our 4a plus 2b plus c equation. So we have 4 times a, which is 0.5, plus 2 times -0.5 plus 6 equals 7. Yes, 7. So we get that 2 plus minus 1 plus 6 equals 7. Now, 2 plus -1 is 1. 1 plus 6 equals 7. So 7 equals 7. Now let's plug it into our very hard equation. Now that's when you know that this stuff is real. So 25 times a, which is 0.5, minus, I'll actually put the minus sign instead of doing that garbage, minus 5 times 0.5. So pretend like I just stole the negative sign the negative sign sort of, it flew away to over here. Plus 6 equals 16. So we get that 12.5. Yeah, I think that's half of 25. Minus 2.5 plus 6 equals 16. And we get that 10, which is 12.5 minus 2.5, plus 6 equals 16. We get that 16 equals 16, and we get that our equation is correct. It is so correct. Ah! 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 So, now we need to just, now that our values are correct, we can now plug it into the equation y equals ax squared plus bx plus c. And we can call it a day from there. Actually, we cannot call it a day because we still have to answer one more question, which is very simple after you derive this equation. So, you have y, or you can also call it t sub n. Yeah, I'll put this in brackets. So call it t sub n equals a, which is 0.5 x squared, plus b, which is negative. Let's change this right now. Actually, let's change it right now. So what we will do is go to this heel and then minus 0.5, just to not confuse you, plus 6. So this is our equation. This is what we should have gotten for problem C. So this is our answer for problem C. Now, it is so stupid that I did not get this on my test, but all I can say is that life's full of moving forward, and if I could get credit for this, it's great, but I just really love math, so it was really fun figuring this out and realizing how much hard work I put into this class to just mess up this problem, and okay, it's fine, I'll move on. So this is our equation, and we want to find, for problem D, we want to find when x equals 30, essentially. So we can, and then we want to find y. So we want to find how many balls will we have when x equals 30. So if you know graph, x is the independent variable and y is the dependent variable, so whatever is changed in x will be changed in y, not whatever's changed in y is changed in x. Only if you're wanting to solve those complicated problems. This is not a complicated problem. So we get y equals 0.530 squared, which I believe is 900. I don't know. Excuse me if I'm wrong. 0.5 times 30 plus 6. So you get that y equals half of 900. My gosh, it's my house phone. That's my house phone, sorry. Which is 450 minus 15 plus 6. And then you get y equals 450 minus 9. Gosh. And then you get y equals 441. Just call it times, I guess. I don't remember the specifics of the problem. I just remember this problem offhand. Again, sorry if this problem is not the exact problem. It was like on the test, but yep. And I don't know, my one tip for math class is pay attention. So pay attention, participate. My 3 P's. My 3 P's for Peterson. Participate. Politeness. And poise. And don't go to pee. If you pee, pee means no progress. So always hold in your pee because you could be missing something really important in the lesson. Yeah, those are my tips. And my name is Ruby Pittman. Pretend that's my signature. And goodbye. Oh my gosh! We're through with the lesson! You've learned how to solve the values for A, B, and C from some values of X, Y, and Z. Not really Z, but it had to rhyme. Okay, bye.